Hi my scholars, this is my school channel and my name is Abiola. For this video lesson, we'll be solving the JAMB CBT past question for the subject physics. For the year 2010, do not go anywhere, stay with us and we'll be right back. Welcome back to my school YouTube channel. For this video lesson, we are going to solve questions 1 to 20. So let's start with question 1. So, two cars moving in the same direction have speeds of 100 km per hour and 130 km per hour. Okay, so what is the velocity of the faster car as measured by an observer in the slower car? So in the slower car, we have the speed of 100 km per hour. So it's just going to seem like the observer right here in the slower car is at rest, okay, and the other vehicle is moving at a certain speed. So at rest, that will just be, just to make this calculation easy, it's just going to be 130 minus 100. So that's going to be 30 km per hour. You know, they are moving in the same direction. So the observer right there in the slower car will just see that, oh, okay, it's like the other vehicle is moving at the speed 30 km per hour. So if it is different direction, it's going to be 130 added to 100. All right, so let's go back to the context of the question given to us, moving in the same direction. So from this observer here, okay, it's just going to be 30 km per hour. So option A is the correct option. Question 2. A stone and a feather are dropped from the same height above the Earth's surface. Ignoring air resistance, which of the following is true? So this setup can be attributed to what the Italian scientist Galileo did several years ago, okay, several centuries ago. All right, so this is what actually happened. You know, he went to the Leaning Tower of Pisa, right, and he dropped two objects, okay, a heavy object and a light object. All right, so it was noticed that both objects reached the ground at the same time when they were dropped from the same height at the same time, like they were dropped simultaneously from the same height and they hit the ground at the same time. Okay, this is basically due to the concept that we are seeing here, ignoring air resistance. So if air resistance was to be put in full perspective, of course we should know that the heavier object, which is the stone, should hit the ground first. But once air resistance is neglected or it is ignored, what you should have is that the feather and the stone should hit the ground at the same time. So let's go through the options together. So we have option A, the feather will be blown away by the wind while the stone will drop steadily, okay, not under these keynotes. So we have option B, the stone and the feather will both reach the ground at the same time. This is very accurate. Okay, so we look at option C, the feather will reach the ground first, no. Option D, the stone will reach the ground first, no, not under this same concept. So the correct option here will be the stone and the feather will both reach the ground at the same time. Question 3. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. Okay, so what is the acceleration of the car? So we know that acceleration is actually the rate of change of velocity with time. Okay, so you can say the final velocity minus the initial velocity over the time taken. So that will be 45 minus 25, that is 20, right? Divided by 10, that gives us 2. So remember the unit is meter per second square. So that will be 2 meters per second square. So that is basically A equals to V minus U over T. Okay, change the velocity over time. So the correct option here is option A. 4. The surfaces of conveyor belts are made rough so as to do what? This is to prevent the loads from slipping. If you know the function of this conveyor belt, okay, so it's going to tell you that the surfaces are made rough, just like the pattern of threading we see on surfaces of car tires, okay, so that it can allow for a firm grip on the road once brake is applied, even though the road is wet or dry. So it's actually the surfaces of the conveyor belts are made rough so as to prevent the loads from slipping in terms of movement. And also, part of the advantages of friction is actually to assist in the gripping of belts. So the correct option here is option B. Number 5. A machine of velocity ratio 6 requires an effort of 400 Newton to raise a load of 800 Newton through 1 meter. Okay, that's the distance. So find the efficiency of the machine. So how do we do this? We just have to pull up some formulas that we are acquainted with. So we can talk about mechanical advantage. MA is actually load over effort, right? So our load is 800 and we have the effort of 400 is applied, so we know year 1, year 2. So our mechanical advantage is 2. We are given the velocity ratio as 6, right? So remember that our efficiency, the efficiency of a machine, our efficiency is actually mechanical advantage over velocity ratio times 100, right? So that should give me 2 over 6 VR times 100. Okay, so 2 year 1, 2 year 3. So that is 100 over 3. 100 divided by 3 should give me 33.3333%. So this is the answer. So let's see if we have this available in the options provided. We can find that in option C. So option C is the right option. So we strongly recommend that you have a JAMB CBT experience, okay, so that you can better understand this concept of your JAMB examination. So how do you do this? Is very easy. You just have to click on the link in the description below. It's going to take you to the Myschool website. Okay, right there you get to download the Myschool mobile app for your Android devices, or you can download the Myschool software for your laptops and computers. So join me as we solve question 6. If a wire 30 centimeter long is extended to 30.5 centimeter by a force of 300 Newton, find the strain energy of the wire. Okay, so we can just use any of this formula, okay? Either we use half Fe. This is force, this is the extension produced in meters. All right, then this is your force constant or the elastic constant. This, okay. So you still arrive at the same formula if you substitute K. Remember K equals F over E. So if you substitute it, you know, it's just going to be times this. Let me write this in this expansion. So that will be half, right? Where K is F over E times E. E squared is E times E, right? So basically I have half times F, then 1E. So you can see that we have the same derivation. So you can see that. So let's just work with this. So first, let's determine our extension in meters. Our extension is 30.5, right? Minus 30, isn't it? This is the initial and this is the extension produced. So let's find out the extension. That is 0.5. Okay, this is in centimeter. We have to bring it to meters. All right, so we're going to do that right here. So we have the elastic strain energy will just be half, right, times the force, which is 300 over 1 times, I know that 0.5 is actually 1 over 2. I'm just trying to convert to fraction, okay? Then remember that it's going to be converted to meters, right? So remember that 100 centimeter equals to 1 meter. So this is what I'm going to have, 1 over 100, isn't it? So I can basically say this, I can put this like this, right? Isn't it? Okay. Or I can still decide to solve my question this way. I can still say 3 over 4, right? This is 3. 1 times 3 times 1 times 1. I have this. 2 times 1, that is 2 times 2, that is 4. I can decide to say 2 year 1, 2 year 150, 2 year 1, 2 year 75. So I still have 75 over 100, so which the amount to 0.75 joules. Remember your units for energy. So you can decide to use this, or you can just punch your calculator. Right, so I should have 4 outside. Okay, so 4 in 30, I know that can only go, right, until I introduce 0 here. that will go 7 times, that is 28. 28 minus this, that is 20, right? 2, I had 0. 4 in this is 5. Okay, so you can see what I have here. So my answer should be 0.75 joules. That is the elastic strain energy that we are looking for. You can see it's similar to the formula of work done when it comes to extension produced. Okay, so this is where we find our option, and that is option A. So option A is the right option. Please do not forget that you just have to hit that like button for us, and also click on the subscribe button, and please tap on bell notifications so you can get alert immediately we upload the next video content just for you. Question 7. In a hydraulic press, the pump piston exerts a pressure of 100 Pascal on the liquid. So what force is exerted in the second piston of cross-sectional area 3 meters squared? So this is very easy. Just take your pressure as force over area, or in this case now we have cross-sectional area, right? So recall that we have F over A. Right now we are looking for F, which is force. What do? We cross multiply. So this will be the pressure, which is 100, right, multiplies the cross-sectional area, that is 3, so that is 300 Newton. Remember, the unit for force is in Newton. So that's the correct option. So let's go and select 300 Newton from the options provided. We can find that in option A. So option A is the right option for this question. Question 8. The accurate measurement of the relative density of a substance in its powdered form is done with a beam balance and a relative density bottle. Okay, so when you're talking about the measurement, you also carry a measurement for powdered form solid, or solid in their powdered forms. Okay, you can talk about solids like your sand or your steel ball bearing. All right, so we use our relative density bottle. The Eureka can, or Eureka displacement can, some will tell you that is used to determine the volume or the density of an irregular solid, or probably like a rock. Okay, then you look at your pipette and your burette. These are useful or used in titration experiments. So the correct option is option A for your relative density bottle. 9. A hydrometer is an instrument used in measuring the relative density of a liquid, okay, based on the concept of buoyancy. So I think where the mix-up should come up, hydrometer or hygrometer, hygrometer. So hygrometer deals with the relative humidity of a liquid, all right? Why this hydrometer is required for relative density of a liquid. So the correct option here is option D, relative density of a liquid. Number 10. One special advantage of alcohol over mercury as a thermometric liquid is its what? Okay, it's its low freezing point, because when you compare them, for alcohol, it is minus 115 degrees Celsius. For mercury, it is minus 39. Okay, another advantage that alcohol has over mercury is that this is 6 times compared to this, okay, when it comes to expansivity at the same temperature. Okay, so, but we should also note that mercury has some advantages over alcohol, like it has higher boiling point compared to alcohol. Okay, so that means mercury can measure higher temperatures compared to this, while this can measure lower temperature, okay, because of the low freezing point. All right, so this is one advantage. Another advantage is the expansivity rate, okay, or expansivity value compared to mercury. So the correct option here is option B for low freezing point. Question 11. The density of a certain oil on frying becomes 0.4 kilogram per meter cube, okay, with a volume 20 meter cube. All right, so what will be its initial volume when its initial density is 0.8 kilogram per meter cube? All right, assuming no loss of oil due to spillage. So we can decide to use the formula density equals to mass over volume. But if you know this simple trick, all right, so we know that there's an inverse relationship between density and volume. So that is, as density increases, volume decreases. As volume increases, density decreases. So that means you can see that the density here, okay, it increases by 2. That is 0.4 times 2 gives us 0.8. Therefore, since density is increasing, what will happen to volume? Volume will decrease. So by how much did density decrease? It decreased by 2. that it increased by 2 rather. That means volume will decrease by 2. Remember inverse relationship. So as density is going up, volume is going down. As volume is going up, density is going down. So that means this is multiplied by 2 to give us this. Inversely, this will be divided by 2. So without solving at all, my answer is going to be 10 meter cube for volume. All right, but I'm still going to solve this, okay, for some of us that like to have it well detailed. So record that density, right, equals mass over volume. Okay, so I should have my mass at first. Okay, so we have 0.4 for density, then 20 for volume. So that should be 0.4 times 20 equals the mass, right? So I know that 0.4 is 4 over 10 or 2 over 5. Okay, so this actually means 4 over 10 times 20. Okay, this is 2. So that means my mass is what? This. So since we are told that assuming no loss of oil due to spillage, so the mass, okay, the mass is the quantity of matter a body contains. So the initial volume now is what we are asked to look for. So we have our new density as 0.8 equals our mass, which is 8 over the initial volume, okay? So if I cross multiply, that will be V times 0.8, right, equals 8. So dividing both sides by 0.8. So this implies that 8 over 1 divided by 0.8 means 8 over 10, right? So the volume, the initial volume is 8 over 1, right, times 10 over 8. So can we see that we arrive at the same destination? So 10 meter cube. So 10 meters cube. So we have it there. So option B is the right option. 12. Heat is radiated by hot objects in the form of infrared rays, okay, at the velocity of light, which is 3 times 10 raised to power 8 meter per second. So the correct option here is option C for infrared rays. Question 13. If a container is filled with ice to the brim, what happens to the level of water when the ice completely melts? All right, so take note of this. We are told that the container is filled with ice. There is no water, okay, in the container before we introduce ice. So if that was done, that means the ice that was introduced, okay, has displaced the same volume of water, okay, that is going to that is attributed to this ice. But this is just purely ice. So there is no water, okay, in the container before introducing the ice. So let's take the question again. If a container is filled with ice to the brim, so that means the container we are seeing is just filled with ice, no water before in that container. So what happens to the level of water when the ice completely melts? So if you understand the abnormal behavior of water or the anomalous behavior of water, okay, you should know that the level of water will drop because very well we know that ice occupies more space, okay, compared to water. So the correct option here will be option D, okay. As the ice melts, the level of water drops. So option D is the correct option. Number 14. The small droplet of water that forms on the grass in the early hours of the morning is what? That's your dew, okay. That's what you get once the air cools below the dew point, okay. So let's talk about mists. All right, you know, mist is just about a suspended water droplet, or suspended water droplet in the atmosphere that is close to the land surface. Okay, that's good. So when mist is severe, what you have is fog. So doing fog, or when the atmosphere is foggy, you know, motorists have to drive very carefully, all right, to prevent accident. Then hail is just we are talking about clumps of ice, of solid ice that fall. So the correct option here is option B for dew. Number 15. So a vapor is said to be saturated when what happens? Okay, at first a saturated vapor is one which is in contact with its own liquid within a confined space. Okay, so a vapor is said to be saturated, you know, when there is a dynamic equilibrium, when there is a balance between the number of molecules leaving the liquid and the number of molecules entering the liquid back, okay, per unit time or per second. All right, so a vapor is said to be saturated when A, that's option A, okay, when a dynamic equilibrium exists between liquid molecules and the vapor molecules. So what is entering, what is leaving, okay, what is leaving, what is entering. So look at option B, a dynamic equilibrium exists such that more molecules return to the liquid than are leaving it. This is incorrect for a vapor that is said to be saturated, okay. So the correct option here, without further ado, is option A, when a dynamic equilibrium exists between liquid molecules and the vapor molecules. We want you to feel excited because you can ask your questions right now. All you just need to do is to click on the link in the description below. It's going to get you to the Myschool website. Okay, right there you get to ask your question on the spot, and our solution providers, of course, will help you out. So join me as I solve question 16. The pressure of 1 mole of an ideal gas of volume 10 raised to the power minus 2 meter cube at a temperature of 27 degrees Celsius is what? So we are talking about the ideal gas equation. So this is what is, okay? This is your gas constant, right? This is your volume, your pressure, your number of moles, then your temperature. So remember your STP. So 27 degrees, if you want to convert it to Kelvin, that will be 27 plus 273, and that equals 300, right? So that's for my temperature. Then number of moles, that's just 1 mole, right, from the question. The ideal gas constant is given as 8.3, right? Then the units. Then we are asked to look for pressure, okay? Pressure is unknown. Then what about volume? I think the volume is given as 10 raised to the power minus 2, which means 10, right? Which means 10, right? 10 raised to the power 2. Or let me just put it this way. Let me make it using indices. Okay, then I have 10 raised to the power minus 2. That is 1 over 10 raised to the power 2. Isn't it in indices? Okay, I'm just trying to see the simplest way to work around this. That means 1 over 100. Because 10 raised to the power 2 is 10 times 10. That is 100. So the volume is given as this. So let's apply this given data. So I have P will be equals to nRT over V, right? When you divide both sides by V. So I have number of moles, that is 1, times your constant, 8.3, or I can say 83 over 10. Okay, since I like to work without calculator, at least for this video lesson. Then I have times, temperature is 300 over 1, right? Divided by the volume. The volume is 1 over 100, right? So if I want to change it to times, this goes up, this comes down. So that will be 100 over 1. Okay, so let's, oh, this is 83 over 10, not 100, please. 8.3, look at 8.3, right? If I want to convert it to fraction, that will be 83 over 10. Okay, so this is what I have here. So I have 1 0. Okay, so I'm left with 83 times 30 times 100. So very easy, just count your zeros. How many zeros do I have left? 1, 2, 3. 1, 2, 3. So let me just work around the number. So 83 times 3. 3 times 3, that is 9, right? 3 times this is 24. So I have 249. Okay? Okay, so that is what we have here, 249,000. So if I'm asked to bring this to standard form, okay, we just count 1, 2, 3, 4, 5. This is where my decimal point is. That is 2.49 times 10 raised to power 5 Newton per meter square or Pascal. Remember the units for pressure. So let's see if we have this or this in the options provided. Yes, we can find that in option C. So you can see in the place of the per, all right, we have raised to power minus 2. So that is still Newton over meter square. So the correct option here is option C, 2.49 times 10 raised to power 5 Newton per meter square. So it is very possible that you have better explanations or better solutions. Please, we are so much interested. All you just need to do is to use that comment section below. Kindly indicate the question number and the steps you'd like to share. Question 17. So which of the following has no effect on radiation? So let's look at option A, nature of surface. So we should know that a dull black surface, right, it emits, is a good emitter and absorber of radiation. Well settled. We know that temperature is very important, okay, when it comes to radiation. Okay, so let's look at surface area. We should also know that radiated heat is proportional to the surface area of the object. Then when it now comes to stopping, take note of that, stopping radiation. You know, you have your alpha particle, your beta particle. Stopping an alpha particle, you can use your thin sheet of paper. Your beta particle, you can use your aluminum foil. Then when it comes to stopping your gamma rays, okay, you need lead. So you can see that lead is thicker than aluminum, at least nothing less than 4 times thicker than aluminum. So for the sake of this video lesson, you know, we are talking about something that has a direct effect. Okay, so we have looked at factors that have direct effects on radiation. So which I'm going to indicate, that's nature of the surface area, and temperature. So for the sake of the video, once again, so which of the following has no effect, or I can say has no direct effect on radiation? That should consider density. So option B is what we are going to stick with. Number 18. So the wavelength of a wave traveling with a velocity of 420 meters per second is 40 meters. So what is its period? So we are just going to use series of formulas together. So at first, remember we have V equals F lambda. Okay, this is your wavelength. So that means I have my F, where I'm going to look for my frequency first, since I'm giving velocity and the wavelength. So that means my F equals V over lambda, and my V is given as velocity, that's 420, over the wavelength, that is 42. So this goes here 10 times. So my frequency is actually 10 Hz, okay? So remember that, recall that frequency equals 1 over your period, 1 over T. So to find my period, that will be TF equals 1, right? So that will be T equals 1 over F. So that is 1 over 10, and that is 0.1. Okay, and the unit. So let's see if we have 0.1 provided. Yeah, very well. I can find that in option D. So we have 0.1 seconds. So option D is the right option. Question 19. The sound of an electric bell dies down slowly when air is slowly pumped out from a bottle because. All right, so we should know that we have different types of waves, or how waves are classified. You know, we have the mechanical waves and the electromagnetic wave. The mechanical waves, they require material medium for their propagation. Examples include your sound wave, your water wave, you know, the wave you notice on a string or a rope, of course. So that means since there is no material medium, air in this case is the material medium that is required. So and air is being pumped out. That means you are creating a vacuum, and sound cannot travel through a vacuum. It requires a material medium. So what happens is that, okay, so let me go back to the question. The sound of an electric bell dies down slowly when air is slowly pumped out from the bottle because, let's go option A, the wavelength of the sound becomes greater in the bottle. No, sound cannot pass through the bottle. Okay, sound needs a material medium. The sound can pass through a vacuum. So we know that sound needs a material medium, else it cannot operate in a vacuum. So the correct option here is option C. Number 20. During a thunderstorm, the sound is heard over a long time. This phenomenon is referred to as reverberation. You can notice this too in halls where musical sounds are being produced. Okay, you see, even after the sound has been made, you still see the reflection of sound. Okay, this is due to probably the materials. Yeah, the materials that are available in that setting. You know, you're talking about the bouncing back from the floors, the walls, the furniture, and the likes. Okay, so diffraction of sound is just that phenomenon whereby sound waves are able to find their way around obstacles. Okay, refraction of sound, you know, when there's a change in direction or speed of waves. Okay, sound wave now in this context. Now superposition, I can just put it simply as addition of two waves. Okay, so the correct option is reverberation. So option D is very correct. We've come to the end of this video lesson, but there are still more wonderful content to come. All we just need you to do is to hit that like button for us. Also, click on the subscribe button and always tap on bell notification so you can get alert immediately we upload the next video just for you.